Welcome back to the Decarb Connect podcast. And this week, I'm really excited to be joined by, well, yet another in our class of disruptors, really. So Anna Douglas, who's co-founder and CEO of SkyNano and co-founder and chief science officer of Aeroborn, is joining us today to talk about carbon reuse. And just a little bit of context here. I guess we all know what CCUS is, but often in that discussion, we get kind of brought in, I think, really to focus on clusters and the sequestration of CO2 underground or under the sea, whereas Aeroborn is really one of a number of disruptors in the CCUS space that allow for the transformation of CO2. So that's what we're here to talk about. So Anna, let me kind of pass to you then. Tell us a little bit about your academic and your research background, and really what's brought you to this moment in time where you're working with both SkyNano and Aeroborn on CO2 reuse.
Yeah, wonderful. Thank you so much for having me. So my name is Anna Douglas. I co-founded SkyNano in 2017, really as part of my PhD studies. So prior to pursuing a graduate degree, I did some work at NASA Glenn Research Center on aerogels, which are a really exciting class of materials that are currently used to insulate the battery pack on the Mars Curiosity rover. And it's really there that I got just super excited about nanotechnology and how material science can impact our world, not just here on Earth, but also in space. And so I pursued a graduate degree in material science to work on energy storage, really with the conviction that, our renewable energy generation is actually really good, and battery storage is really today the big bottleneck to a sustainable future. But along the way, we realized that the way that we produce a lot of materials that go into electrical energy storage, like batteries, are not very sustainable. And it just puts a huge burden on the battery's performance to perform for a very, very long time to offset that initial carbon burden. And so I started looking at other ways to produce carbon materials that could be used for batteries, for tires, for plastics, coatings, all kinds of things, and came across this electrochemical process that has been studied since the mid-60s and really had only been looked at as how to capture and store CO2 as solid carbon. But throughout my PhD, I helped co-invent new ways to derive the formation of specific carbon structures from this process. And that's really where SkyNano was born. So we're a spin out of Vanderbilt. We've been funded by the Department of Energy, the National Science Foundation, the Department of Defense, and some initial customers. But at SkyNano, we're really focused on the production of highly valuable carbon structures like carbon nanotubes from CO2. And that, that's very specific in terms of the market and what we can do with the materials. We've partnered with some colleagues to form a joint venture called Aeroborn to deploy the core technology to make lots of other different kinds of carbon structures, like carbon black specifically, because it's a different market. It's more widespread, it's more high volume of a use case. And we just knew that this had to be more of a global effort in order to deploy this technology as fast as possible to make a really big measurable impact on our carbon in the atmosphere.
Okay, and then for the kind of lay people out there, like me, can you just give a kind of use case for both the kind of carbon nanotubes that you mentioned, but obviously we're here to talk about Aeroborn, so a little bit more on where might people recognize carbon black being used? What's the different use cases for those?
Yeah, so, in both cases, the materials that we're making are used for additive based applications. So for anyone who doesn't quite understand what that means, your tire, that you drive or you ride in your car or your bike or whatever, that has carbon in it. And today it's carbon black. And tomorrow it will probably be carbon black, hopefully with a little bit of nanotubes in it. And the reason for that is because, we really need carbon to help electrically ground our tires to the ground. If you didn't have it, when you get out of a car, you'd actually get a static shock. And there's just a great way that carbon black and carbon nanotubes work together in a lot of systems, tires being one, but your battery in your EV or in your phone or in your tablet or computer, that also has carbon in it. And so there's a lot of different ways that carbon helps improve the performance of our materials and devices. One is electrical conductivity, and that's a big one. Carbon is conductive, and so it helps create conductive networks within materials and devices that need them. Another is just as a dye, as a colorant, right? So in a lot of plastics and rubber components that just need to be black for aesthetic reasons, carbon black is what's used to color those. So it's really everywhere around you. A lot of people have no idea that this material even exists. And yet you really can't go through a day in sort of, modern society without interacting with a ton of different materials and devices that have carbon already embedded in them.
What I loved when we first got in touch about doing this podcast was the idea that at Sky Nano, you have this kind of premium product opportunity of the nanotubes, and in Aeroborn you have the kind of mass market, if you like. I don't know if that's the right phrase, but a kind of a real volume play. Both of those have this benefit of a solid carbon outcome from CO2 capture. So I remember you saying to me that that was one of the big wins of the technology. Yes, it's great to see CO2 being reused in any number of ways, but what's so significant about having a solid carbon output, in your opinion? And just tell us a bit more about that.
Yeah, that's a great point. So the big benefit of a solid carbon product is that it is not re-emitting CO2 in its life cycle. And I say that slowly because I want everyone to hear it. It is not re-emitting CO2 in its life cycle. And what I mean by that is, there's a lot of attention and a lot of effort being put towards, renewable fuels that are made from CO2. They're called a bunch of different things: renewable fuels, e-fuels, all different kinds of things. And that is great. And we will probably need that for aviation applications for quite some time. Outside of that, it is hard to justify making other things from CO2 that would re-emit CO2 in their life cycle. It's not permanent storage, and there's been enough scientists who have told us at this point, we need to start taking CO2 out of the atmosphere and permanently storing it in order to get our climate under control and avoid going, beyond 2 degrees Celsius, above pre-industrial levels. And so what that means for us at Aeroborn and at Sky Nano, we're really focused on solid carbon products, and particularly those that displace products that are conventionally petroleum derived, that emit CO2 in their life cycle, in their production. But then also, go into applications that have the potential for energy savings. So things like batteries, tires, efficient coatings, things like this that can actually help improve the performance of conventional devices, that really have a pretty meaningful impact on sustainability and on our overall carbon atmosphere. When you take all of that into consideration, the production, the offset of producing conventional materials, and then the life cycle overall. It's actually a pretty impactful way to impact the environment and have a pretty measurable impact on carbon.
I think it's really interesting that most of the time when we hear people talk about permanent sequestration, the kind of anxiety is all about, well, can those reservoirs, can those holes in the ground, if you like, really prove that they can hold CO2 there for 100 years plus permanence, and actually there's something so neat about, why not sequester it in the things we use, why Absolutely. Not sequester it in products we need? And there's a kind of neatness to that as a solution that I think can grab people's attention.
Absolutely. And, when we talk about permanence, this is very stressful, right? We typically talk about, you mentioned 100 years. I often see, things like 1,000 years permanent. How would you ever measure that? And how would you feel so confident when you're putting CO2 into a reservoir that beyond a shadow of a doubt that there will be no leakage from that reservoir? Why would we put that stress on ourselves? Let's just make things from carbon, right? Let's just make products from CO2. And a lot of folks are doing this. And so why not? And I think a big, push that we have at Aeroborn is really to make products from CO2 that compete that are cost competitive with conventional products and materials. And therefore, there's really not a huge reason not to use them. As long as they perform similarly to conventionally made materials, and these markets are growing, we need more ways of making these materials anyways. It's a win-win-win.
Talk us through, and bear in mind, there are the simple folk like me who just, we don't have the same kind of scientific background. So walk us through this process. You mentioned that it's not the process in itself is not new. It's been around for 50, 60 years. So tell us about this, how does it work, and how you've developed it beyond the original, process you came across.
Yeah, definitely. So we're relying on an electrochemical dissociation of a carbonate-based salt. And there's a lot of big words in there, but basically at its core, our chemistry relies on a carbonate salt. So very similar to baking soda. That's a carbonate salt. And, we dissociate that into carbon and oxygen, and what's left is a metal oxide. And that's actually what's responsible for chemical absorption of CO2 to regenerate that carbonate salt. So that's the chemistry. And that in itself has been around, since the mid 60s. And our very unique take on this is the specific electrode architectures that are required to drive the formation of specific carbon structures. And what I mean by that is, for a while, people had been studying this technique to make all different kinds of carbon structures, but there wasn't really a great deal of understanding on how to control those, on how to drive, carbon nanotubes versus carbon black versus carbon fibers, or whatever it is. A lot of folks just looked at the basic chemistry or the basic electrochemistry, and we approach this from a very strong material science and material synthesis background. And that's, I think, what's very unique, and that's where a lot of our intellectual property is around.
Congratulations. I think I managed to follow that, but interesting. So the takeaway from that is that one of the key differences is that being able to properly predetermine the nature of the structure that you're creating from that process, and that's what sets it apart from what was happening before.
That's right.
Yeah. Okay. Well, one thing you mentioned before you were talking about the process was this kind of, can you create products that are cost competitive? So we're going to talk in a moment about the stage of development that you're at, but what's that looking like in terms of product compared with existing product? How is that cost comparison?
So that's, it's been a pretty big driver for any market that we look at. How can we compete on a cost per cost basis, provide customers with a product that is the same cost as what they're using, or even less, to help with switching decisions. But that's really enabled by the fact that, our only inputs are CO2 and renewable energy. And so what that means for us right now is we're selecting CO2 offtake partners who have incentives to get rid of their CO2, right? So this may be either just they've made public commitments to net neutrality, or they're geographically located in areas where there exists a carbon tax or a carbon tax is coming. And, we're looking for really low cost renewable electricity. So we're very specific on site selection of where we choose to locate based on the availability of those resources. And beyond that, we've got a lot of freedom and a lot of room to work. A lot of electrochemical techniques to convert CO2 into solid carbon products will have very similar constraints, right? So a lot of them will need CO2, ideally from a freely available source, or someone who's willing to pay to offtake their CO2, and low cost renewable electricity. So, for anyone who's site planning, city planning out there, these are resources that you might want to have around to have some really exciting startups come move to your region.
That's a good point, actually, isn't it? If you want to be the new location maker for kind of carbon management, carbon tech disruptors, it is that heady combination of access to the problem as well as access to the cheap renewable fuel that's going to make the difference.
That's right.
Okay, well, so tell us then the stage of development you're at. So both in terms of, process, what's proven, what scale, but also a little bit about the team. What road are you on at the moment?
Yeah, so at this point, we've got a pretty strong team of 3 founders and one I would sort of say late stage founder, first employee. But so we are a team really of very diverse backgrounds. So the co-founders in Aeroborn are, myself, very, very strong science background, very technical. And then we've got a really great marketing background on board who serves as our CEO. So he's done a lot of marketing efforts with, really exciting companies like Nike and Tesla. And so that's a really good fit for us. And then at the same time, we also have a co-founder who spent the majority of his career as a global VP for Shell. And so, he worked for a very long time, I think did very, very well at Shell, worked his way up the ranks and, realized at some point, I got to do something positive for the environment. He's just been around and knows just so well how to take something, maybe not necessarily from 0 to 1, but from 1 to 100, how to scale things fast and deploy technologies globally. That's really where his strength is. And so it's just such a high octane team. And then our first sort of non-founder early employee was actually an early investor in Aeroborn, and he's got a really strong legal background, really, really strong personal conviction to do something positive for the world. And so there's just this great mix of personal passion, personal conviction with skills that are really needed for these kinds of technologies to come to fruition. So that's a team. We are growing. We are certainly looking for partners. So we partner with an engineering firm to do some of the basic engineer design, taking from where we are today, which is proof of concept, scientific discovery has already been done. We've demonstrated, the basic technology at a lab scale. We've got a working prototype. It works. It's awesome. We can actually start to partner with folks who have a CO2 challenge to, kind of take their unique blend of CO2 output as an input to our process and see what kind of carbon products we get out. So that is a partnership that we offer to CO2 emitters right now. And, really just looking for that first pilot plant. So that will happen next year. We're working with a development and engineering firm in the Netherlands to build a pilot plant there as sort of a first demo unit. And that'll really be, kind of the first step towards rapid scaling for this effort. So it's a very modular technology. We can scale very modularly. And so for that effect, once we kind of get the first demo done and learn as much as we can, it should actually be a pretty quick scaling effort from there.
And the kind of timeline for the Netherlands demo plant, what's currently on I know we all know in the last 18 months has shown us that things can change. Thank you, COVID. But what's the timeline to that demo plant?
Yeah, so we're looking to start the engineering work to designing that demo plant actually late January, and it should be, fully built and working by the end of the summer of next year. Well, pretty rapid timeline.
Pretty rapid. So let's just take a step back though and talk about these kind of proof of concept studies. Talk to me about like what does a proof of concept study look like? What should I expect of that? And are there particular sectors, particular manufacturing bases that you're, kind of really eyeballing to work with at this point, or is it across the board?
These are good questions. In terms, I will start, I guess, with the first one and then go to the second answer. So in terms of the ideal customer or the ideal partner for us, we offer a solution that can really help hard to abate sectors. And that's relatively unique, right? And so there's a lot of technology solutions that can help folks who just, need to switch to a more renewable energy source. That's not, we offer something that's much more difficult than that. And so for those folks that, I'm not really sure that we would be the best fit. For us, the really big fit is for hard to abate sectors, things like steel, cement, energy production, that's not switching to renewables anytime soon. Things like this where, we can take essentially any kind of CO2 output as an input to our process. And we've got a really wide range of what can work. So anything from, a really highly concentrated CO2 source that does exist in some places, particularly across the EU, all the way to, a more dilute source. So, things like the flue gas off a natural gas power plant, I think is something in the ballpark of 10 to 12% CO2. That's fine. So we can take, really dilute sources up to really concentrated sources. And what we would do, how we would work with an initial partner is, we would say, well, what do you want, right? They probably want to know, can you take all of our gas? Do we need to do any kind of pre-treatment before it goes to Aeroborn, or can we just take it as it is in its entirety and run it through our system, and then what comes out? And so that's really where our proof of concept study is centered on. We would start with a synthetic blend. So all we would ask for a partner is just tell us what kind of gas blend you're interested in. That may be 10% CO2, 20% nitrogen, and the balance oxygen, or whatever it is. We would say, just tell us that. That's all the data we need, and we'll run it through our system, and we'll see what we get. We'll see, what comes out, if there are any constituents that are problematic, and if there are, we'll do some digging on how we might remedy that, how we might get rid of those before they go through our system. And that's kind of the basic understanding of how an initial proof of concept would work. And then we would work together with that partner to determine, what kind of business relationship is most amenable to them. For some folks, they may be able to use the output carbon in their process, in their product, right? So things like cement, right, for example, often are looking at carbon additives to increase strength. So that may be a really great fit where they're more of a licensor. They can just take the technology, avoid their own CO2 emissions, and use the end products. But there may be other customers, like a power plant, for example, who don't really have any uses for carbon black. And so then we would go set up on site, right? And we would take their CO2 emissions, and then we would be responsible for the final product. And so, it really kind of starts with this proof of concept study of what can we do with your output, and how does that work? And then we would move into an engineering phase of, okay, how much CO2 are you outputting, and how much would you like for us to get rid of? And a lot of folks, particularly in very heavy emitting industries, are well aware that it's probably going to take, a puzzle of a few different solutions to fully decarbonize. And so, we would then just look at, well, what balance do we need to take care of? And then move into an engineering phase of, okay, let's design a demo unit at, a plant of interest, and kind of go from there. But, this kind of goes back to what I had mentioned earlier. Really, the resources that we would need for a site are just a source of CO2 and a source of low cost renewable energy. So as long as we can access both of those, there's really no limitations on what sectors, what customers, and what CO2 emitters we can help.
And you mentioned needing to understand the nature of the kind of flue gas mix. And this has come up in a couple of things before, and this is a total layman's question, but you were talking about it in terms of the density of the CO2, the actual kind of the mix of it. But I know I've heard from other, some CO2 reuse and other companies just doing capture, that there are other particulates, other things that can cause issues. So why does that matter so much to these different types of technologies? And again, apologies to listeners as much as to Anna, because I'm sure many people know this, but why would those different particulates or constituent parts matter so much?
Certainly every CO2 capture or utilization technology is different, right? Every single one may be affected by a different kind of impurity or particulate or whatever that might be. Something that we're very specific about is we like a dry CO2 source. So because we're working with electrochemistry, once you put water into electrochemical systems, things tend to start to go awry. Water is pretty straightforward to remove from gases, right? You just condense it and you can pull it out. So that's pretty straightforward for us. In terms of other technologies, particularly for direct air capture, I can imagine for a lot of these, you're looking at absorbents that may be in sort of porous frameworks. If those can kind of become plugged, for lack of a better word, with larger particulates, that's very problematic. That's not something that we have to deal with at Aeroborn, but certainly, we are still in relatively early stages of assessing exactly, for each customer, it's just going to be a little bit different, the different kinds of output gas, and what constituents or impurities may be in those, and how we have to address those.
Thank you. Thanks for putting up with that kind of
It's not a tough question. It's actually very important.
feel like I'm doing a GCSE in carbon capture with you, but thank you. So let's move on to something slightly different. Then there is always a bit of a kind of happy tension, a kind of useful tension whenever there's new technology being innovated. Well, in this case, the manufacturer wants and needs innovative tech to move forward, but often you will always find some people who are willing to step up, some companies that step up to being that early adopter and that early tester, but always companies that are hesitant about perceived risk or challenges. And I'm interested to understand, like, how are you encountering that, and how are you working through that with kind of potential customers?
Great question. I think a big thing that doesn't necessarily get brought to light as much is the realization that, this can be a good business decision, and this is a good business decision. Many heavy emitting industries are realizing that they're at a massive risk in terms of, just one stroke of a pen and carbon policy or carbon taxing changing, right? In a lot of different geographies where we may not have even anticipated this moving so quickly. And it's just good business to start de-risking that position as early as possible. And the reality is, of course, everyone's going to want a technology that's ready to go the minute they need it. They don't exist today. That's where we're at. They don't exist today. We need them to exist at scale as soon as people need them. And so, a lot of these industries are at just a huge risk. You're talking like a relatively low carbon tax could take away, it's only 50% of many of these industries' revenues, leaving them quite literally underwater. They have to be investing now. And so I think we are seeing a lot of folks doing that once they realize what kind of risk they could be in. And for those who don't, realize that yet, it's just good business. You don't have to come at this from an altruistic standpoint. Certainly we appreciate those who do. But it's just good. It's just a good business decision to start investing early in these technologies, particularly because other people are. And you don't really want to get left behind, right? And so what we're seeing, as I kind of walked through how we would work with an initial customer, there's a lot of development that happens very specifically for a specific CO2 output, right? And so if you're a heavy emitter industry and you're kind of looking around and seeing what's out there, don't you want to know that something is out there specific towards your CO2 output, right? Something that has been very specifically tailored towards what you have to offer in terms of CO2 gas output and how someone can take it in. And so investing early in these technologies, Aeroborns and others, is just going to be really key to a stable business economy moving forward.
I'm always interested to hear from companies on all sides of this kind of issue of industrial decarbonisation about what's needed next. And inevitably there's some mix of, well, the banks need to do this and the politicians need to do this. And so what's your mix? What is it that you need to see for companies like Aeroborn, but not just Aeroborn, to really flourish?
Yeah, so I would say there's four big things that need to happen, and they come from a variety of stakeholders, as you have already mentioned. And the four big things that really, really need to happen, two are from industry and two are from government. And the two from government are, of course, we need more policies that help drive new innovations in decarbonizations and really incentivize new technologies to come to market. And this doesn't look like what the existing policies look like, right? So the existing policies often only incentivize folks when they get to a really, really large scale, right? So 45Q in the US has been a landmark policy for helping decarbonization efforts, but you only can start to get the credit if you're decarbonizing like tons and tons and tons and tons of CO2. And so that's really hard for early stage companies to rely on at all until they get very, very big. So, it certainly helps incentivize big companies to decarbonize, but it doesn't help newer, earlier startup technologies really break into the marketplace. So I would say more flexible policy is a big one that we just need. The other thing from governments that we can really use is be the example, right? If you're buying a fleet of cars, for example, make sure those cars not just are EVs, but have, low carbon components as part of their makeup, low carbon composites, low carbon tires, low carbon interior, etc. Set an example for what the supply chain looks like, and it's not just cars, it's everything that a government may procure. Set the example of, hey, we're going to incentivize lower carbon suppliers in the supply chain from A to Z, right? From the very start of a product to where we're procuring it, everyone in that supply chain, has got to be as low carbon as possible. And you don't need to pay like a huge premium for it. But, if you're saying apples to apples, we're within 10, 20% of the cost of a conventional product, the low carbon product's going to win. So I would really love to see that from governments. And we've got a few ideas on how that can happen. And then, certainly I would say at the same time for industries, number one, invest early. You got to invest early in these decarbonization technologies to make sure that one is going to be ready for you when you really, really are at risk and you really need it. So of course, partner early, invest early. And then the other one is also for businesses, particularly those that have made a big public commitment to net neutrality or decarbonization in some effort. Look at your whole supply chain. 2020 and 2021 have taught us a lot about how vulnerable supply chains are, just in terms of, labor and availability of materials throughout entire supply chains. Well, we should really start to re-examine them in terms of carbon footprints at every stage as well, too, right? And so if you're a big car manufacturer and you're getting ready to switch to a fully electric fleet, that's great. Don't put dirty tires on your car then, right? So, make sure every component of your supply chain is as clean as possible. And consumers are really starting to figure this out. I think a lot of consumers are voting with their dollar in terms of sustainability. And we've seen this shift even in the absence of a lot of policy. And so I think there's a lot that, both stakeholders, both industry and government can play in this. But, as consumers, we can also say, hey, I'm not going to buy an EV unless it also has low carbon composite materials as part of its makeup. So, really having a good understanding of the whole supply chain, I think is pretty critical.
Yeah, and of course, one of the things that can help drive that, which I guess they're starting to talk about in Europe, I don't know if it's a discussion yet in North America, is labeling, or labeling is a very consumer level way of looking at it. But those decisions by a willing consumer, so someone like me is a willing but probably fairly poorly educated consumer a lot of the time on things like that. But if when you're buying your new car or you're buying whatever it is you're buying, you can clearly see what the kind of distribution of CO2 and other emissions are across. I think that's the game changer as well, isn't it? All right. Well, Anna, thank you so much. I mean, really fascinating to talk to you. Also interesting to hear from someone involved in this early stage tech who also has this background at NASA, because this was the same for Tara Karimi at Semvita. And there are some really interesting kind of people I'm coming across who have these kind of multiple reasons why they've kind of gone down a certain path, or the kind of science and materials that they were exposed to in other circumstances all becoming part of this picture. So really fascinating. Thank you so much.
Thank you so much for having me. It's been great fun.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.